Okay, so if you're looking for a video which is a crash course in IGCSE 0607 Maths, then this is the video for you. I'm going to go through the 10 main topics that appear every year, and if you have these in the bag and you really understand these topics, then you'll do really, really well in the IGCSE 067 course, and you'll be well prepared for 60, even 70% of questions. So my very first topic is, of course, going to be GDC skills. So we have a typical GDC question here. So f of x is equal to x cubed minus 5x plus 3. We are given a scale here and we need to sketch it. This is the classic GDC question. So I am now going to open up my GDC and I'm going to type that function in. So in the graph function here, we just press x cubed. Now the easiest way of doing this is clicking on this button here, giving you the index, and then you can put in the 3. There we go, minus 5x. And then we are going to go to plus 3. So we type that in, and you'll notice it doesn't quite look like what we need, because if we go back to our PowerPoint, you'll see the scale is given from minus 3 to 3 and from minus 10 to 15. So we need to go back to my GDC, and we go to Menu, Window, Window Settings, and then we put in the correct settings. So I'm going to put minus 3 here. For here, I'm going to put 3, following the instructions of the question, and then we have minus 10 and positive 15. So you must change the window to fit the question that you are given. So we have our typical cubic shape here. Notice it crosses the x-axis 3 times, it crosses the y-axis once. So we're going to copy that across and make sure we have a good sketch. So let me get my pen ready. So it goes up, it crosses in the positive quadrant here, and then we go upwards like so. So there's a 2-mark question. I imagine the mark scheme would be looking for it crosses it 3 times, where 2 are in the positive and 1 in the negative, and it crosses here once as well. And now we need to find the coordinates of the local minimum point. So notice this is our minimum point here. So we are going to go straight back to our software. We are going to go to Menu, we go to Analyze Graph, and we're going to go to Minimum. And when we do this, we know the minimum's around here somewhere. We click before it, we click after it, and then we can read off the value for our minimum. Okay, notice that you are going to need both coordinates here, and we want to do both to 3 significant figures. So we have 1.29 and minus 1.30. So we write in 1.29 and minus 1.30. Always play on the safe side. Make sure you write this to 3 significant figures. Now, question C has been quite tricky for a number of students over the years, where they've tried to fit in or crowbar in this rotational symmetry into a GDC question. I've seen this now a couple of times, so be aware of this. Notice it's a 3-mark question, so we need 3 pieces of information, and we need to describe fully the symmetry of the diagram. The first thing we should recognize here is there is a rotational symmetry. Imagine this is our center of our rotation. It would spin around and actually look the same as we spin it around, and it will look the same twice. So we have to write down rotational symmetry. So for 1 mark, order 2, because if you visualize this in your mind, you can rotate it around once when it's the same and then back to the beginning, so to give you twice. And we also need to know where the rotation point is. Well, this is going to be our y-intercept. Now we can actually, without using the GDC, actually read this off, because the y-intercept is always the number in our function. So this is actually going to be 3. So we just put in 0, 3 as our center. Again, 3 marks, they require 3 pieces of information. So make sure you do not leave anything out. Okay, and now we go on to part D. This is very, very typical for a GDC question, where they give you another function, in this case a straight line, and then you need to solve the equation. The amount of times I've seen people try to equate these 2 things together and then solve it, you simply can't do that with IGCSE methods, possibly with IB methods. So we need to use the GDC way of doing this. So let me show you very quickly how we do this. So if I go to our GDC, like so, we press the tab button. This is a very useful shortcut. If you press the tab button, you can then type in the second function straight away, And remind myself, yep, it's 2x minus 1. So you go 2x minus 1, press enter, and you'll get a straight line that goes across like so. Now the question wants us to solve this. Notice you got 3 marks, and that makes sense because you have 1, 2, and 3 intersection points. So we're going to work out these one at a time. So we go to Menu, Analyze Graph, and then we are going to go to Intersection. And we do it in the same way that we did it with minimum maximum. So we click before, we click after. You can just about see we scan this in, and we get minus 2.90. So we are going to type that in our first part, minus 2.90. Notice we're looking to solve, so we only want the x values, okay? That's important to realize. Okay, and then we're going to do the same process for the other 2 points. So we go Menu, Analyze, Intersection. We click before, we click after, and this time we get 0.603. Again, be accurate with that 3 significant figures. So 0.603. Let's go back again. Almost therapeutic doing this. Menu, Analyze, Intersection, and we click before, we click after, and we get 2.29. So go back to our PowerPoint and write in 2.29. Get 1 mark for each of these points. Now this is the part that is really that discriminator question between A and A star, so we need to be careful here. Use your answers in part 1 to solve f of x is greater than g of x. So if I was to do a quick look at my GDC, what we're looking for is when the function, the blue function, is bigger than the red function, okay? And we've already worked out the intersection points, and hopefully you agree here, the blue function is bigger than the red function between this point and after this point, okay? So we're going to write that now in mathematical notation. So the way we do this is using inequality. So using the points that we just did, we have minus 2.90 is less than x. Let's be careful with the inequalities. Notice we've got a strict inequality here, not less than or equal to. So we know between these 2 values we just worked out that x, the function f of x, will be bigger than the red function that we had. But also, and this is what people forget, x is also bigger than 2.29. So you're using these values, and then you're saying to yourself, okay, when is the blue function bigger than the red function? Okay, I need to write this as an inequality. Okay, and this gives us the 2 marks. 1 for the first one and 1 for the second one. Okay, and my number 2 topic is going to be statistics, and it can appear on paper 4 or it can appear on paper 2 as well, and really be prepared for those cumulative frequency star questions. So let's get on to question 4. So the marks x of 300 students in a chemistry test are shown in the table below, and we need to calculate an estimate of the mean mark. Now notice we have grouped data here, therefore we do not know how many people got exactly 1 mark or 5 marks or 7 marks and so on. So what we need to do is work out an estimate, and the way we do this is working out the midpoint of these different categories. So we're looking for halfway between 0 and 10. That is going to be 5. Halfway between 10 and 20 is 15, and so on. So we go through this process like so. However, you do have to be careful. So the halfway between 40 and 60, that's going to be 50. So don't watch out for that sneaky trick where they change the class widths. Between 60 and 80, that's going to be 70. And then finally between 80 and 100 is 90. Now, we could do this manually, but one thing that we do have in our possession is a graphical display calculator. So I'm going to show you how this works and can work this out really, really easily. Okay, so you see I've got my graphical display calculator here. So I'm using the TI Inspire. So we go to On, we're going to go to New, and we're going to create a new spreadsheet, a very useful function. What I'm going to do is I'm going to call this M for midpoints, and I'm going to type in all the midpoints. And now here for the frequencies, I'm going to type in all the frequencies. Okay, and once I've got this, I go to Menu, I go to Statistics, Stat Calculations, 1 variable statistics. Notice we only have 1 variable in this situation. And now my X list is going to be M, frequency list is going to be F for frequency, makes sense. I click OK, and you'll see the very first value you get here is our mean, this X bar, which is 39.817. So I'm going to go over and write that into my PowerPoint. And this is going to be our answer, 39.8. Remember, always round to 3 significant figures if you are not sure. Question B, we're going to complete the cumulative frequency table here. Now remember, this phrase, cumulative frequency, this means a running total. This is a really important topic to understand if you want to do well on this IGCSE 0607 course. So the way we work out cumulative frequency, we start with our value 41 and then we keep adding these values on. So we do 41 plus 32, that's equal to 73. Then I go back, I take 73 and then add on 44. So 73, 44. If we do that, we get 117. I go back, and now I want to add on the 50, so 117, that previous value, plus 50, and then we get 167. And we do this same process going back, adding this value, popping it in like so, until we get all the values. And one thing you can do to check in the exam is when you do the very last one here, so 280, and then we add on that 20, we should get to that last number here of 300. So make sure you're really, really careful about actually putting these values in. What we're going to do now is actually put these values onto our cumulative frequency graph, where we're going to plot the 10 against the 41, the 20 against the 73, and so on. So this one is 20 and 73, so we go 20 along and 73 up. Try and not get dizzy when looking at these. So 60, 70, just before here, 73. Just keep doing this in a nice logical manner. Now be careful with this one here. Notice we've got 60 and 232. So don't do 50, make sure you do 60 here. Okay, so I've got all the points here. So when we connect this up, this must be a smooth line that goes through all the points and make sure it's increasing at all times. So I'm going to start at 0, 0, work my way along. Again, try my best to get a smooth curve as possible. That's not too bad considering I'm working on a computer. So part D, we're going to use this curve to now work out an estimate for the median mark. So notice we have 300 pieces of data here. So to work out our median, officially what you should do here is do 300 plus 1 divided by 2. It's important for the plus 1. But notice on the graph it's not going to make much difference here. So we get 150.5, and we're going to look for the 150.5 value. So I'm going to get a different pen color here, and I'm going to go to 150. I'm going to go all the way across and then read down. So we just go dot, 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 dot. Make sure you use your ruler at home. Very important to do. If you're liking this video as well, feel free to give myself a like. It does go a long way to help the channel. Okay, and if we read the scale here, going along in twos, so 32, 34, 36. So I'm going to pop in 36. And notice in the mark scheme, the answer goes between 35 and 38. Now we go to do our interquartile range. So to work out the interquartile range, we need to work out two things. First, we need to work out the lower quartile, and we need to work out the upper quartile. So 1/4 of the data and 3/4 of the data. So this formula is very similar. We do 300 plus 1 divided by 4. Very similar to this, but we didn't just halve it. So notice we're going to get the 75.25 value. Again, 75 will also work here as well. So I'll use a different color here for interquartile range. So I'm going to do this in magenta, lovely color. So we're going to 75, which is here. I'm going to go across and downwards. So I'm getting that value there to be 20. Now let's choose a different color for the upper quartile on the graph. So this one here, we're going to take this value, just the lower quartile, and times by 3. If we do that, we'll add these two together as well. We're going to get 225.7 value. So let's choose a lovely color here. Let's go with cyan, why not? So 225, so it's roughly here, a little bit above this line here. So again, we have to be really careful as we go across. try making this process essentially as accurate as possible. Okay, downwards like so. We're going to read that value off. Again, hopefully I've been accurate enough for the mark scheme. So I get here 58, pop that there. And the way we, from those figures there, actually work out the interquartile range is we're going to take one away from the other. So 58, which is our answer here, minus 20, giving us the answer of, and that fits in within the boundaries. I'll show you the answers here. So it fits in within this boundary of 35 to 39. Okay, so 35% of the students pass the test, and we're going to use that curve before to find an estimate of the minimum mark needed to pass. So if 35% of the students pass the test, we actually need to find where it is actually equal to 65%. So we know that cutoff between either passing the test or failing the test. So we need to find 65% of the 300. So we're going to do 65% 300. And again, you can use your calculator to work this out by doing 0.65 times 300. But if you do that process, you will get 195. So I'm going to do a very similar process to what we did before, but this time we're going to go to 195. So I go back to my graph like so, and I'm going to use yellow this time. That's a nice color to use. We go to 195 here. We draw a line all the way across, similar to how we did the quartiles and the median, and then we go down at this point, and this will help us work out the cutoff point between the students passing or failing the test. So you'll see the value that we get here is equal to 48, and that's the value we're looking for as our estimate for how many marks are required to pass the test. So our answer here is going to be 48 marks. And what this value means is this is the kind of cutoff point where anyone above 48, that you're into that 35% passes the test. Okay, so you can quickly check your answers here. Again, appreciate any likes, and if you want to subscribe, that also goes a long way to support the channel as well. And this is the last page of the answers for question 4. Okay, and my number 3, which is coordinate geometry. Often appearing on the paper 2, occasionally appears on the paper 4. And what I'm going to do with you is really go through a detailed question here, going through perpendicular bisectors, going through gradients, and how to apply that also in a geometric context. So A is the point 32 and B is the point 95. So we are given these on our diagram. I tend to like to write this in, just so it reminds me what they are. And we need to find the length of AB for a pretty generous 3 marks. So let me draw this line in. So we've got the line AB. I'm really not known for my line drawing, and we want to find the length of this. So the way we do this is the standard procedure. So we are going to make a right angle triangle out of what we have here. Okay, as soon as you see a line segment kind of question, you need to be thinking right angle triangles and then Pythagoras. That's what comes with it. So let's work out then what the lengths of my triangle are. So notice the x-coordinate here is 3. The x-coordinate here is 9. What's the difference between 3 and 9? That's going to be equal to 6. We do the same thing for the y. So what's the difference between 2 and 5? That's going to be 3. And at this point, we can use Pythagoras. So AB squared is the same as 3 squared plus 6 squared. Again, most of these things you can use a calculator to work out. 3 squared is 9. 6 squared is 36. 36 plus 9 is 45. But remember, this is AB squared. So to get our final answer for AB, well, what's the opposite of squaring? Well, square rooting. So we need to square root the 45 at the end. And this is the paper 4. So we're just going to use a calculator to work this out. Here's a handy one I've got. So I go Control, square root, 45. Press the enter button and I generate my number here, 6.7082. Remember, we always round to 3 significant figures. So I'm going to go back, and what I would do in the exam is write down what's on my calculator and then round it afterwards. So we're going to round to 3 significant figures, first, second, third. Because we've got an 8 here, we're going to round the 0 up to 1. So we get 6.7. I don't think there are any units involved here. We weren't told any units. So that is fine. Next question, we need to find the equation of the line AB. Give your answer in the form y equals mx plus c. Now the good thing about doing the method that I've done here is that we've kind of worked out some of the information that we need. Remember, the gradient is equal to rise over run. It depends on your teacher, they teach you different things, or the change in y over the change in x, or that formula y2 minus y1 over x2 minus x1. The thing is, here we've actually got the information we require. Okay, so the rise is going to be 3 and the run is going to be 6. So the gradient is going to be equal to 3 over 6, which if we simplify our fraction to a half. So by using this method, we've kind of got some bonus information for this question here. At this point, I can then write my line in the form of y equals mx plus c. And now I know that m, the gradient, is equal to a half. So I just write down y equals a half plus c. But I need to work out this constant. And the way we can do that is just taking any of the coordinates. We can take this one, or we can take this one, and we substitute it in. So when x is equal to 3, y is equal to 2, and then we're going to put that in here. So where I see a y, I'm going to put a 2. Where I see an x, I'm going to put a 3. And let me continue this slightly over here. So we've got a half times 3 is 3 over 2 plus c. And now we're going to minus 3 over 2 from both sides, which is 1.5. You can use a calculator for any of this. And 2 minus 3 over 2, that's going to be 1 over 2. But again, use your calculator to confirm. Okay, and then we have to write our answer in. So I'm going to write y equals a half x plus a half. Notice the marks can actually use decimals, but again, fractions is absolutely fine. That's a nice 6 marks to get in the middle of an exam, yeah? It should make you feel comfortable here to get those 6 marks, and then we'll go on to the harder questions. Okay, so now we're given an extra point. C is the point 8, 2. So let's put that roughly on our diagram so we've got an idea of where it is. 8, 2, well, that's going to be along here somewhere because this is 2. So let's pop it here. Let's pop it there, 8, 2, to make it more or less, in the right place. And what do we need to do with it? Find the equation of the line perpendicular to AB which passes through C. So let me draw this visually. So what we're looking for is a line like this that goes through C and is perpendicular to AB. Okay, so it's slightly different than the perpendicular bisector. We're just looking for a perpendicular line that goes through C. Right, so the first thing we need to do is work out the gradient of the green line. Well, let's have a think about that. There we are. So the gradient of AB was a half. So the gradient of the green line, well, there is a formula here, but the way I tend to teach this is to work out the gradient of a perpendicular. We flip the fraction, so we get 2 over 1, and then we switch the sign. So we have a plus here, so we're going to switch that to a minus. Again, we don't usually write this, minus 2 over 1. We just write this as minus 2. So the gradient of the green line, the steepness of the green line, is equal to minus 2. At this point, we do this very similar to how we did the previous question. We write it in general form, y equals mx plus c, y equals minus 2x plus c. And at this point, we substitute this coordinate in because we know it's on the line. So when x is equal to 8, y is equal to 2. Let's pop that in. So 2 is equal to minus 2 times 8 plus c. Always running out of room here. There we are. We're close. So I think at this point, you add 16 on both sides. There we get c is 18. And so we put this back into the general equation. So perpendicular line will have the equation y equals minus 2x plus 18. Just be careful. It just wants a perpendicular line. It doesn't want a perpendicular bisector, i.e. you do not need a midpoint in this case. Okay, and we are going to continue. So find the coordinates of the point where the line in part C intersects. Okay, so we see this green line that I drew kind of randomly, and now we actually want to find this point here. Do we have a name for this point? Nope, we're just going to find that random point. Now notice this is the intersection of two lines. Now we've got the equation of both lines. We've got this one, so let me write this down. So we've got y equals a half x plus a half, and then we've got the previous one, so y equals minus 2x plus 18. Now if they intersect, then it means that these two equations are equal to each other. So we set the right-hand sides equal to each other. What that means in practice is a half x plus a half is equal to minus 2x 18. At this point we solve this like a normal equation. So what I would do first is bring the x's to one side. So I'd add 2x on both sides. That's going to give me 5 over 2x. Okay, because this is 4 over 2. Okay, if you're not sure about that, you can convert it to decimals if that makes you feel better. Plus a half is equal to 18. There's a reason I've kept it as a half, as we'll see shortly. So if we minus a half from both sides, I'm going through it nice and steadily. Ignore my alarm. So minus a half from both sides, this cancels with this. Okay, I should have said this cancels with this. That's why it disappears. Then we get 5 over 2x. Well, 18 minus a half is 17 and a half, which is the same as 35 over 2. The reason I've kept it all like this, I can now cancel this from both sides. And notice I've got a really nice equation out of this. And I'm going to get the coordinate of x equals 7. I'm not finished at this point. So we've got the 7 coordinate, but now we need to work out what the y coordinate is. You can substitute now 7 into either of these equations. So I'm going to substitute it into this one, but it doesn't matter which one. So when x is equal to 7, y is equal to minus 2 lots of 7 plus 18. We work through algebra and then we get the answer of 4. Again, please do feel free to stop the video if I've gone through a little bit too fast. That's absolutely fine. That's why we have the videos. It makes your life much easier. Okay, part E, D is a reflection of C in the line AB. Okay, in the line A. Okay, so, right. So D is going to be up here somewhere. So if I continue this line, and this would be D. It will be on the same line, because it's perpendicular. And what we need to work out is the coordinates of that. Yeah, coordinates of D. Okay, the first thing that will come to mind is writing that intersection coordinate that we just worked out. So 7, 4. So this was 7, 4. And then we think to ourselves, well, this distance needs to be the same as this distance. So there's a gap of 1 between 8 and 7. So there needs to be a gap of 1 between 7 and this coordinate. Therefore, this would be equal to 6. And the same principle applies here. So there should be a gap of 2 between 2 and 4. So we need a gap of 2 between these coordinates. So we need to add on extra 2. And that gives us our coordinate of 6, 6 for 2 marks. Be interesting to see what they say for working here. Okay, they don't give any marks for working here. They just say you get 1 mark for each coordinate. Okay, and now we need to know the special name of quadrilateral ACBD. Make this so ABD. Aha, okay, so let me use a different colour so we can see exactly what shape they want. So A to C, this. Now the better you make your drawing, the easier it is to see what shape this is. I think I've done a pretty decent job of this. I think we can see that this is a kite, yeah, because this distance is the same as this distance. That's one of the definitions of it being a kite. So we just write in the correct mathematical word, which is like so. Okay, and on to question F. So we need to find the area of this quadrilateral ACBD. And I did have a think about this, and I don't like the way the mark scheme does it. So what I'm going to do is draw this out again. So I'm going to draw out the rough kite that we have. Try and do it, to decent scale. So we've got A, okay. And the general formula for working out a kite is to take these two sides I'm putting in, times them together and divide by 2. Now we already know AB, we already know this is root 45. So all we need to do is find DC, which we can do by using right angle triangles. So the same way we did the previous question. So D was 6, 6 coordinates. C was 8, 2 down here. So we can work out the length of the line segment using Pythagoras in the same way we did before. So we've got the height, the difference between 6 and 2 is 4. The difference between 6 and 8 is 2. So we can use Pythagoras to work this out. So we get x squared is equal to 2 squared plus 4 squared. X squared is equal to 20. So x is equal to root 20. So then to work out the area of this, all we do, the area, is going to be root 45 times root 20 divided by 2. If we put that into a calculator, so I'll just do that now. So root 45, 20 divided by 2, that gives you the answer of 15, which is the exact answer, the precise answer. So we get the answer of 15. There are no units in this case, no centimetres squared or anything like that. I think the mark scheme wanted to use like AC and CB and do it in a similar kind of way. But I think this makes much more logical sense. But again, feel free to leave a comment in the comments what you think, whether you think there's an easier way than doing it how I did here. I'll just show you the mark scheme though. It's always interesting to see how they do it as well and where you pick up the marks. So again, pause your video. You can go through yourself if you're doing it with me. And then the last question here, which I didn't follow any of these methods as far as I'm aware. Actually, I think I did this method here instead. I think that makes more logical sense than this one here. Before we move on, of course, the exams report. So most people did well in the first 3 parts of the question, which makes sense. It's pretty standard, lining perpendicular lines, etc. But yeah, as we went through into D, for example, realizing that you can just equate it. I think that was part D or part E. And also you need to find the midpoint. That wasn't the case. You need to find the intersection point instead. Again, clearly drawn diagrams. Notice I thought it a little bit overwhelming. So what I did is I drew what I needed for the question and then put in the correct information. That helped me shape my thinking for working out the correct solution. Okay, and my number 4 is probability. Now this generally appears in a tree diagram question, and this is the question I'm going to go through with you, and it's the most likely to appear in your exam. So we have a probability question. Trisha's got 2 bags. In the first bag we have 6 white balls, 4 red balls. In the second bag, 4 blue balls, 3 white and 2 red. She takes a ball out at random out of the first bag, then takes a ball at random out of the second bag. So there is no replacement. It is with replacement, i.e. there's no change in probability between bags 1 and 2. So it stays as is. And we need to complete the tree diagram for 2 marks. So if we take our first bag, the number of white balls there are 6. And we have 10 balls in this total, so this will be 6 out of 10. And then for the probability of red, there will be 4 red balls of 10 as well. Now we have a completely different bag. So for the second bag, there are 4 blue balls, so it'll be 4. And then how many balls are there in this bag? Well, let's be careful. 4 plus 3 plus 2 is equal to 9, so we get 4 of 9. Likewise, with white, we have 3 out of 9. Red, we have 2 out of. And notice it'll be the same regardless of whether we chose white or red beforehand. It will still be the same probabilities. So 4 out of 9, we have 3 out of 9, and finally here 2 out of 9. Nice for 2 marks. Certainly that's marks you should be picking up in this paper for exam. Now they ask you some probability questions linked to this. So first of all, we want to work out the probability that Trisha's 2 balls are both white. So let's go back. So we want the probability of white, white. Tend to write it. And the way we do this is we take the probability of the first one being white, 6 over 10, and then we multiply along the branches. So we multiply this by 3 over 9. And remember, to multiply fractions, we times the top, so 6 times 3 is 18, and then 10 times 9 is equal to 90, and we should simplify at the end if we can. I'll leave this there for a future calculation. Generally speaking, on IGCSE Cambridge, they don't mind if you leave it like this, but we should try and simplify it, and if we divide top and bottom 9, we get then 2 out of 10. Bottom should be 10 and not 9 because we're dividing by 9. Top, to show you what we did there, and here, and here, and then we get to our answer over 5. But I'll just show you the mark scheme here quickly. So notice if you leave it as 18 over 90 on this exam, or OE, or equivalent, that's absolutely fine. You get your 1 method mark for 6/10 times 9ths. That's wrong. It should be 9 here, not 10. So a mistake in the mark scheme. But that's fine, we know what we're doing. 18 out of 90, so write that. So writing the working, 6 over 3 over 9, that gives you 18 over 90. Notice that's all I need to write. Now for this one we need to be slightly careful. We need one white and one red, so that can be either way round. This is important. So we want the probability of red white plus the probability of probability of white red. There we are. Let's not get those mixed up. So let's go back. So the probability of white red, so let's do this one first. Well, that's going to be 6/10 times 2/9. Notice I'm not going to simplify at this point, so 12 over 90. And then we work out the probability of red white. So white, no weds, just reds. So we get 4/10 times 3 over 9. There we go. And we also get 12 over 9. And so we want to use these two answers here. I mean, I would usually write this working on the other page, but I'm working between two slides. So our answer is 12 over 90 plus 12 over 90 is equal to 4 over 90. Now I know with the mark scheme I can leave it like this. Kind of different to what they teach you in year 7, 8 and 9. You always simplify whenever you get the opportunity. Tree diagrams is one of the few exceptions to that. So we get 24 over 90. Biggest mistake made on this question is you don't take into account both ways round. So you need to do white red and red white. We show you the mark scheme here. Okay, so 24 over 9, fine. Now part 3, we want to make this as easy as possible for us. So we want to work out the probability that they're different colours. So notice you can either have two balls that are different colours or the same colour. Okay, it's one or the other. And all probabilities have to add up to 1. So a quicker way of doing this question, rather than working out everything individually, is doing 1 minus probability of the same colour. Because whatever we're left with after we work out the probability of same colour is that it must be different colours. The reason I do it this way is that we've already worked out some of these things. So we've already worked out the probability of both white, which is 18 over 90. So all we now need to do is work out the probability of red red and blue blue, I think the other colour was. Blue blue, exactly. And then we can just work it out from there. So what I'm going to do is just work out the same colour. In fact, it's even easier than that because we only have blue in the second ball, not the first ball. So all we need to do then is actually work out the probability of red red, which if we times these two fractions together, we get 8 out of 90. And that's the only way we can get two of the same colour, probability of white white or red red. Okay, so I'm going to bring that over, this answer here, minus 8 over 90. Now, remember, 1 on its own is 90 out of 9. This is why I did not simplify to make the subtracting fractions much easier. And then if I do this calculation, well, 90 minus 18, well, that's going to be equal to 72. 72 minus 8, well, that's going to be equal to 4 over 90, yeah? Which, as we saw in the previous mark scheme, not need to be simplified. So I'm going to leave it as 64 over 90. And there's our answer there. So one thing I want to mention with this question is don't always think you have to do things in always the same way. Look for opportunities to save yourself time. And this is a good opportunity. Think, of different colours. Well, if I work out the probability of things being the same colour and do 1 minus that, I will get the answer much, much more. Okay, and you'll see the actual exams report actually mentions this. So the probability of different colours was a little more challenging, but well answered by many candidates because they took this longer method of working out white red, red white, red blue, blue red, blue white, white blue, and added them all together. Whereas if you use the more efficient method like I've just mentioned here, you'll find that's much, much more. So particularly in an exam which is 2 hours, 15 minutes long, you want to look for ways to make your calculations more efficient, and this is one possible way. But notice this question is generally well answered, so you need to be getting all the marks here to make sure you're heading for those top grades. And my number 5 is percentage calculations. Now this generally appears near the start of a paper, so it goes through things like compound interest, simple interest, and working between them, as well as some reverse percentage change. Right, question 1. So Asif buys a 1-year-old car. He pays $19,975, which is 15% less than its price when it was new. calculate the price when it was new. Now, one thing that I do notice in these kind of questions, and it's something I highlight to my pupils as well, is this question is in the past tense. So it says when it was new. So that's what we're looking for. So as soon as you're working backwards in time, you need to be thinking reverse percentage problem. That's the first thing that comes to mind. Now we're paying 15% less than the price when it was new. So essentially this price that we have here is essentially 85% of the original price when it was new. So we can say that 85%, that's 100% minus 15%, is equal to the price that ASIF bought it for, which is $19,975. What we want to find is 100%. We want to find the original price when it was new. So we need to find some way of going from 85% to 100%. Now, we can go directly. That is a method that we can use. What I tend to recommend to students is finding some kind of intermediary step. And what I would recommend to do is work out 1%, this so-called unitary method, and then from 1% we can really easily find then what 100% is. So the way we can go from 85 to 1 by multiplying or dividing, well, we can divide by 85, and then once we've divided by 85, because 85 divided by 85 is 1, then we can multiply by 100 to give myself the original price. Doing it in 2 steps, but you can see my very, very clear working here. Whatever we do to the left-hand side of an equation, we of course do to the right-hand side. So we're going to divide this side by 85 and times by 100 in the same way. So this is where I get out my GDC and then actually work out what this is going to be. So let me now open up my GDC. So I've changed the format slightly here. So I've made it kind of bigger so you can really see what I'm doing. So I've got the calculator on the left-hand side here so you can see what buttons I'm pressing. So you've got 19975. We're going to divide that by 85. This gives me 235. So I'm going to go back to my PowerPoint and I'm going to write that in, 235. And at this point you can use your calculator to times by 100, that's fine. But remember, times by 100, we're just going to add 2 zeros on. So we get our final answer of 23,500. Generally on paper 4s, they give you the units here already, so I don't need to worry about putting dollars in at the end. So my final answer will be $23,005. Nice and clear working, so even if I got this wrong for whatever reason on my GDC, I would still get my method mark for the working I've shown here. All good. All right, let's move on. Okay, so in part B, ASIF's got 2 different options to actually pay for the car. The first option is you can pay 10% of the $19,975, which he's paying for the car, and then pay $345 a month for 5 years. Option 2, you can actually borrow the $19,975 and pay this back at the end of 5 years at an interest rate of 2.5%. We'll look at that in part 2. So ASIF can pay using either option. Using option 1, how much will ASIF pay in total for the car? So we're going to work out option 1. Well, the first thing to notice here is that paying 10% of that $19,975, well, 10% is essentially the same as saying 1 over 10. So what we can do to work out the total amount here is we take the 19,975, we multiply that by 1 over 10, that's essentially the deposit, and then we're going to add on the extra that he pays over the 5 years. Well, he pays $345 a month, so we're going to get 345 times 12, so 12 months in the year, and then he's doing that for a total of 5 years, so we're going to times that by 5. Notice being very efficient with the working here. I haven't written any more than I need to. So at this point, I'm going to take this calculation and I'm going to put this straight into my GDC to generate an answer. Okay, so I'm going to type this straight into my GDC. You can see what I'm doing over here. So I'm going to put in 19975 multiplied by control fraction 1 over 10. Okay, and then I'm going to add on, I'm going to put this in brackets, so $345. We times that by 12 months in a year, and then times that by 5. And if we put that all together, We get a fraction, but that's fine. We can just press Control Enter to give us the decimal that we're looking for, which is 22697.5. We're going to pop that back into my calculation. So we get 26750. Now, usually we always say round to 3 significant figures. That's really, really important. However, when it comes to money, we need to put the exact value in here. So notice we're in dollars and cents here. So we do need to put 22697.50. That's really, really important. You don't want to lose an accuracy mark at this point. You'll get 2 method marks for the calculation I've shown, and then 1 for the answer here. Okay, on part 2, we look at by how much is option 2 cheaper than option 1. So now we need to work out what option 2 is. So I'm going to write very clearly here. We're going to do option 2. Now here we use the compound interest formula. So the way we do this is we take 19975, so $19,975. We multiply it by the multiplier. Now if we're increasing by 2.5% a year, the way we work out the multiplier is we do 100% plus 2.5%. That will give you 102.5%. And we want to convert that to a decimal multiplier. The way we do that is divide by 100, and we'll get 1.05. So we put this into our compound interest formula. So we put 1.025, and then we work out how many years we're going to be paying this interest for, which is 5. And by doing this calculation directly, this will give you the total amount of money that ASIV has paid for this borrowing from the bank. So we pop that into our GDC, and let's get an answer. Okay, and we're going to type this in. So 19975 multiplied by, and I tend to put this in brackets, 1.025, close brackets. The power button is over here on the left-hand side. We pop 5, we press enter, and we get our answer like so, 22599.9. So we pop that in. Okay, and at this point we just then take one away from the other. So in order to work out how much it's cheaper, and good, this is cheaper than this, so that's very, very good. We get 22697.5. We take away 22590. And then if we work this out, we'll get the following answer. So let's just work this out now. And I'd round this now to the nearest dollar and cents, so I get $97.62, like so. So just show you the mark scheme here. So you can see 97.62 is the precise answer for your 4 marks. And you can see the method here. I went straight into 1.025 rather than writing as a fraction, which is absolutely fine. So you can check your answers here. One thing to show you before we move on to question 2 is the examiner's report. You should be aware that this thing exists. So generally this was a well-answered question. And the first part was a reverse percentage question that was generally answered well. Just make sure you don't add on 15%, but use divide by 0.85 or the method I showed you. And already mentioned this point here, which is that you do not want to round any money answers to 3 significant figures. What you want to do here instead is you want to actually write the exact value here in dollars. And number 6 is not to be underestimated, transformations. So make sure you've got tracing paper. Make sure you ask your teacher to have tracing paper, as this also comes up very, very often as well. Okay, and question 2. So a very typical transformations question. This is something you really should revise if you want to excel at the paper for. So let's go through this. So describe fully, first of all, the single transformation that maps triangle A onto triangle B. So it's a 2-mark question. Always use the amount of marks to guide how much detail that you need to put. The first thing we need to notice here is that going from A to B, we're just moving the shape essentially, which we call a translation. So you need to know these key words. So I'm going to write down translation, which essentially means moving the shape. And as soon as you talk about translation, you need to be thinking of vectors. So we're going to do translation by the vector, and then we're going to write how it's actually moved. We put this in bracket notation like so. The top number tells you how much it goes left or right. So let's work out what's happening here. So to go from A to B, I'm going to take a point here and match it up to a point over here. So we're going to go 1, 2, 3, 4. So we're going to go 4 to the right. So we put a +4 here. And if you're in the exam and not entirely sure, you can always check another point. So if we take this point and this point, for example, then we can check 1, 2, 3, 4 to make sure we've done it correctly. And notice that we're not going up or down with our triangle, so the number here is going to be 0. So we get a translation by vector 4, 0. 1 mark for translation, 1 mark for 4, 0. Our next part is we're going to take triangle A and we're going to reflect that in the line y equals, no subtitles, y equals minus x. So what we're going to do is we're going to take the original triangle here, the triangle A. Always read this carefully if they want you to do triangle B or triangle E, etc. And we're going to reflect that in the line y equals minus x. The first thing we need to remember is what does the line y equals minus x look like? So y equals x is this line going all the way up. So the line y equals minus x is the 45-degree line going in the opposite direction. So let me draw this in. So I'm going to try this. First time I've been using the pad, so let's see how straight this is. Not too bad. Probably needs a little bit of work. If you're not sure where this comes from, well, let's have a look here. When y is equal to minus 1, then x has to equal to positive 1, so that's true. So you can check coordinates here to make sure you've got the correct line, y equals minus x. And what we're going to do here is do a reflection. Now I'd highly recommend that you use tracing paper to do this. This is perfectly allowed on IGCSE. Without tracing paper, this is also fine as well. So let me choose a different pen colour. Let's go with magenta, why not? So we take a point on our triangle, we take the corresponding point that's perpendicular, so at a right angle to that point, and then we transfer it across to the other side. So we've gone 1 to the left and 1 down, so we need to go 1 to the left and 1 down. So this purple point here, if we reflect it in this line, reflects over here. Again, use tracing paper, it will make your life much, much easier. Let's take another point, let's do this in blue. So if I take this point here, and I make a perpendicular line, so a line at 90 degrees, to that blue point, notice there's a right angle here, I go 2 to the left and 2 down, so we go 2 to the left and 2 down, and then we get to this point here. Notice this should be the same length as the line over there. And let's do it for completeness. Let's see if I can get a different colour. Let's go with, I don't want magenta, I've already used magenta, I want to use yellow, there we are. So we take this point here, we do the same analysis. This is a bit trickier because we're halfway in a box. So we're going to go from here to here. So you can see this is a right angle. We are going essentially 1.5 along and 1.5 down. So we need to do the same thing. And then we'll come to here. Again, tracing paper makes your life easier. Once you've done the 3 points, either using tracing paper or using the method I've done here, then you can just draw in the triangle like so. Not the best triangle in the world. We're going to label the image C. So make sure you label this for your examiner C so they know the triangle that you've actually drawn. That is probably the worst triangle I've ever drawn, but you can see the idea here. For part C, we're going to go back to this original triangle A, and we're going to rotate this 90 degrees clockwise. Remember, clockwise goes in this direction, following the clock, about the center 1 minus 1. Notice we're not using the origin, we're not using the center point here, we're using a different point, so we're going to be using this point here, 1 minus 1. Which I'm going to put in black. Again, use tracing paper, so put tracing paper over the shape, draw around it, mark in the center of rotation, and then spin it 90 degrees. However, we don't have access to such clever things here, so we're going to do this manually. So notice that in order to work out the rotation, we know it's roughly going to be over here, because we're turning this direction. The way we would find this out, to keep it fairly straightforward, is that it's going to make a right angle with where the new point is going to be, and it's going to be the same distance as well. So this point here is going to be rotated to here. When I've got this reference point, then I can fill in the rest. So I know that it's going to look like this. Again, you can visualize that in your mind that this is coming around to here. But in order to know where it's going to be, which is the most important thing, you need to find a reference point. So you use this point to here. But again, use tracing paper. It will make your life much easier. We are going to label this D. So we've done this question, and this question. And the reason we label it is exactly for this type of question down here. Part D. Describe fully the single transformation that maps triangles C to D. So essentially want to go from this triangle to this triangle here. Now the first thing to notice here is there's a reflection going on. So we need to write down then reflection, and it's a 2-mark question. I'm using that as a guide here. So we need to provide another bit of information, and that is the reflection line. So we're going to have a reflection in the line. Remember when I first taught GCSE and IGCSE, they're very fussy about the prepositions you used, but now they're fine, just a reflection in the line. And I think we can see here that the line is going to be this vertical line going all the way down. And we can check this at this point here is 2 away from the reflection line, and this is also 2. So we can use that as a check. Now let's think about how we identify this line. Well, if we take all the coordinates on this line, so this is 1, 5, this is 1, 4. If I go down the bottom, this is 1, minus 5, etc. What do all these coordinates have in common? And they all have an x equals 1 in common. That gives me the name of this line then of x is to 1. 1 mark for reflection, 1 mark for x equals 1. Now for the last part, I'm going to get rid of the pen because we need to be able to see what is going on. There we are, like magic. And what we're going to look at here is the single transformation that maps A to E, so going from this to this. And you first look at this and think, well, it's not quite an enlargement because it's not in the same proportion. It's not a translation either because it doesn't look the same like A to B. So then we have to think, it's like an enlargement and it's kind of like a translation. What would be kind of in between? And that would be a stretch. Now make sure that you have learnt about stretches. This is something that often gets forgotten by IGCSE teachers. Make sure you know how to do stretches as well. Now this is a 3-mark question in comparison to these 2-mark questions, so we need 3 bits of information. So first of all, we have a stretch. The next thing that we need to work out is our stretch factor. Okay, so I'm going to put stretch by factor. And now let's have a look at this. So let's take corresponding sides. Well, this side is 1, and this side here in comparison is 2. So like an enlargement, we compare the sides and go, well, this is 1 and this is 2, so we must have a stretch then of factor 2. And the last part, which is probably the most trickiest part here, is actually working out what the stretch, where the stretch is actually occurring from. And we call this the invariant line or the invariant axis. Yeah, I'm going to call this invariant line because you don't know whether it's an axis or not. And then we need to work out where it's being stretched from. So let me go through that nice and carefully. This is probably the hardest part of the question. The easiest way of doing this is a kind of trial and error basis. So, for example, if I take the x-axis, which is going to be our correct answer, but let me show you why that's the case. We look at corresponding points. So this point here and this point here of our shape. The distance from here to here is 1. Whereas if I take the distance from my supposed invariant axis and this point here, that is going to be 2. Now let me take another point. Let me take the top point of our triangle, do this magenta. If I go from this point to this point, this is going to be 2. But if I go from this point here to all the way up to the top, this is 4. So you can see there is a consistent stretch going on from this particular line, and that's what we're looking for. Likewise, if I do this for completeness, from here to here is 1, whereas from here to here is going to be 2. So for every point in my triangle, there is a consistent stretch upwards. And if you find this consistency, then you know you found the correct line. So actually here we have an invariant axis, not an invariant line. So we're going to call this by invariant line the x-axis. I'm going to write in purple because why not? So we get 1 mark for stretch, 1 mark for factor 2. Notice this is not an enlargement factor, it's a stretch factor, so I'm just writing factor. You usually don't lose a mark for this, but just be careful. And then our invariant line, so where the stretch is happening from, is the x-axis. Think of this as if you're putting your foot on the actual line and then you're stretching the shape upwards. That will give you a good idea of what is going on. So let me show you the mark scheme. So we've got a translation 4, 0. These are the coordinates of the triangle I reflected and rotated. Reflection x equals 1. And then stretch, 1 mark. factor 2 or stretch factor 2, and the x-axis is our invariant line. Okay, I put invariant line, but as long as you've got invariant there, that is important. Quickly go through the exam review after this exam was done last year. It was well done by most candidates. Yeah, you do need to put translation. That's really important. You can't just put move, for example, or shift. Not good enough. Most B, C, and D were generally done correctly, and many students got the stretch as a type of transformation with scale factor 2, but finding that invariant line is that discriminator question between an A and an A star. So do make sure you know it. And my number 7 is a tricky topic for the IGCSE standard. This is functions. So working with composite and inverse functions. And I'm going to go into a detailed question that goes through the very typical kind of questions you are going to see. Okay, and on to some functions for question 5, a very typical paper 4 question. So we're going to start with some substitution here to work out f of minus 2. So to work this out, wherever we see an x in our function, we're going to replace it with minus 2. So I'm going to copy across the 2. I'm going to put a minus 2 where the x was, and then leave everything else alone. And then we just have to do some calculation here. So 2 times minus 2, that's equal to minus 4. Minus 4 minus 1, that's equal to 5. And for the second question, it's a very similar kind of process here. So we're going to work out g of minus 2 first of all. So I look at my g function here. Wherever I see an x, I'm going to put a minus 2. So we get 3 minus minus 2. Notice you've got two minuses there. And if we put those together, we get minus and the minus is a plus. So 3 plus 2 is a 5. Now this question is slightly different because we take that answer now and now put it into our h function. So we're going from right to left. Our final step is to work out h5. And then we put a 5 where the x is in our h function. And we get 5 squared, which is equal to 5, which we pop over here. The next one is a typical follow-up question to this, where you need to take the whole function and make it equal to something. So notice our function here is 2x minus 1. So we're going to write in 2x minus 1, where the f of x is equal to 7. And from here, this is a straightforward solving equations. So we want to get the x on its own. What's the opposite of minus 1? Well, we're going to add 1 on both sides. This cancels here, leaving us with 2x is equal to 7 plus 1, which is 8. And then what's the opposite of timesing by 2? Almost gave you the answer there, dividing by 2. And if we do that to both sides, we then get our answer of x is equal to 4, which we'll pin over here. So you really need to, if you want to get that grade C on this paper, you need to make sure you're getting those first 5 marks correct 100% of the time. Question C is a typical composite function question. I'm going to write here the word composite, and we always work from right to left. So what do I mean by that? Well, we start with the g of x function. So g of x is equal to 3 minus x. So I'm going to replace that here with 3x. And in order to work this out, so I'm going to put the entire function here. So let me put this under magenta. So wherever I see an x in my f function, I'm going to replace this x with the 3 minus x. Now, what does that look like? Well, let's put that in. So we get 2, stays as normal, open brackets, 3 minus x. So I've replaced the x here with a 3 minus x, minus 1. And remember, this is not the finished answer here. You need to simplify. So we're going to expand out the bracket using the hook. So 2 times 3 is equal to 6. 2 times minus x is equal to minus 2x. Don't forget our minus 1 over here. And then if we bring it all together, 6 minus 1 is 5. And get our final answer of 5 minus 2x, which you need to have simplified to get mark. So then we go over to question D, which is a kind of slightly strange question here. It's kind of untypical. So we need to solve this kind of function equation. So again, we just substitute in the functions that we have here into the equation. So f of x is equal to 2x minus 1. We need to multiply that by g of x, which is 3 minus x. Then we're going to add on 2 lots of h of x, so 2 lots of squared. And this is equal to 0. So essentially this is a quadratic question, sort of wrapped up in function notation. At this point we need to then expand the bracket using FOIL, first, outside, inside, last. So 2x times minus x is minus 2x squared. So then we can do the first term here, 2x times 3 is 6x, minus 1 times 3 is minus 3, and then minus 1 times minus x, positive x. Don't forget our 2x squared over here, and that's equal to 0. And you can do this in lots of different orders, but as long as you make sure you multiply everything by everything. Now notice here, this is something quite convenient. We have minus 2x squared here, we have a plus 2x squared here. These two things cancel, that's super. We have 6x plus x, well that's going to equal 7x, minus 3 can't be simplified, and now we've got actually a really straightforward equation from that. It looked very complicated at the start. So if we now simplify this, well we do it in the same process we did before. So let me just pop this over here. We've got 7x minus 3 is equal to 0. What's the opposite of minus 3? Well, plus 3 on both sides. This cancels. We're left with 7x is equal to 3. And now at this point, what's the opposite of timesing by 7? Divide by 7 on both sides, giving us our final fractional answer of x is equal to 3 over 7, which I'm going to write in like that. The decimal would also be acceptable as well. And now we've got the classic inverse question here. So we're going to find the inverse of the g function here. So we do this in 3 easy steps. Number 1, we set this function equal to y. So y is equal to our g function, 3 minus x. Step 2 is we swap over the x's and y's. So we do x is equal to 3 minus y. And our third, more complicated step is to make y the subject. Okay, so I'm going to write that down because that's really important for inverse functions. Make y the subject. If you follow those 3 steps, you can do any inverse question. Algebra is complicated, but you can do it. So the way we simplify from here, I'm going to add y on both sides. Thinking, why is that? Is that going to help? Well, we'll see in a moment. So we get x plus y is equal to 3, because these cancel. And then finally, because we want y on its own, we do, what's the opposite of adding x? Well, we're going to minus x from sides. And if we do that process, we then get our inverse function, which is y is equal to 3 minus x, which is, kind of cool really, because, we had the initial function 3 minus x, and its inverse is the same function. So it's equal to 3 minus x. You can show this actually graphically. It's quite interesting to see. And number 8 also likes to come up regularly as well. This is the sine cosine rule bearings question. Okay, this can be a good question with lots of marks, and it's relatively straightforward as long as you see the patterns within the question, which I'm going to go through now. Very, very typical sine cosine rule bearing question. So we've been given some various angles and some various sides, and we need to calculate various lengths and angles and areas. So our first thing we need to do is calculate the length of AB. So that's this length here. Notice we have a right angle triangle, we have an angle on the side. That really looks to me like SOHCAHTOA or basic trigonometry. So if I draw a very quick sketch like so, this is 150, this is my right angle, like so, and I've got an angle here of 55 degrees. As you know with SOHCAHTOA, we label the sides and angles. This angle here, well, it's opposite this side. This is the hypotenuse, the longest side, and of course the other side is going to be our adjacent, like so. And now we want to find AB, the adjacent. So we want to find the adjacent. We know the hypotenuse, so we're going to use cosine. So I tend to teach it using triangles. It's not the only way. So cos times h and a. So these are the triangles for normal SOHCAHTOA, cos a and h. Now we are looking for the adjacent, so we cover up the adjacent. So we do cos of the angle times the hypotenuse. So we do the calculation of cos 55 times 150, like so. And now we work that out on the calculator. So I'll do it on the GDC on my desktop. So we need to make sure it's in degrees. That's very important. So let's start a new document. So we won't save that because we've already done that. Add calculator. You can even type in cos 55, but I'm just going to use the standard function here. So cos 55, we want times y, and let's just go back and check 150. So we type in 150, we get 86.0. And quick check of the units, it's meters yet, so generally we do it to 3SF, so we get 86.0. Okay, all good. Now calculate the bearing of D from A. So we want the bearing of D from A. So we start at A and then work our way around to D. So we need to find this angle here. So D from A. So we start at A, work clockwise around until we hit D. So we've already got two of these angles already, this one and this one. So all we need to do, and let me use the eraser, is find this angle here in the triangle. I always forget where the eraser is on this. Okay, it doesn't matter, but we need to find this angle here specifically. Okay, and we've got, well, 1, 2, 3 sides. Okay, so we've got 3 sides. We want to find an angle, so we need to use the cosine rule, but for an angle. So let's call it the cos of C is equal to A squared plus B squared minus C squared all over 2AB, where C is the side opposite the angle, so it would be 235 in this case. Now, you're probably wondering, how did I get this formula? How do I know this formula? Well, first I learned it off by heart, but if we go to our formula sheet right at the start, let me scroll up quickly, notice actually in the formula sheet here, we have it only in terms of the sides, so A squared. So this formula I just given, I'd recommend learning off by heart, so you don't need to put yourself under pressure and rearrange this formula to get cos A, in this case, the subject. Notice with this formula, it would be cos A equals B squared plus C squared minus A squared over 2BC. So it's A is going to be the angle you focus on, whereas here I'm using C. Both are absolutely fine, you can use. So if we work this out, so we've got 120 squared plus 150 squared minus, size would be sticky, minus 235 squared, all divided by 2 times 120 times 150. And once we've worked this decimal out, so we'll get a decimal of some kind. So let's go back to my GDC. So we want to do it as a fraction, so we go control and divide. 120 squared plus 150 squared minus, I think it was 235. That's it, 235 squared. Oh, don't want the answers. 5 squared. The calculator is pretty clever at working out biz maths as you go along. So times 120 times 150. But we'll do a common sense check at this point. So we get that. And if you press Control and Enter, we'll get to decimal. And you need to ensure that this decimal is between -1 and 1. Otherwise, you've done something wrong. However, we want to, that was the cos of the angle, so we need to find the inverse cos of that answer. So we go to trig, cos inverse, and I want to work out the answer, so I go Control here, and then press Enter. I get my angle, which is 120.599. So I go back, and so my angle C is 120.599. But that's not the end of the question. So this angle here is 120. So we still need to add on 70 and 55 to work out our final answer. Kind of running out of space. So I'll put answer is equal to 120 dot, plus those 12 angles, so 70 and 55. I need to make sure this is a 3-figure bearing as well. So go back to my calculator. Again, try and never round too early. It's one thing I say to my students a lot. So if I go control answer plus 70 plus 55, I then get the total bearing, which is 3SF 246. So I'll come back to here, write in bearing as 246 degrees, like so. Okay, excellent. Right, one more question to go, and then I'll stop the video for the moment. So calculate the area of the field ABCD. So essentially, we've got two triangles here. I think the easiest way of doing this is to work out one triangle at a time. So let's call this T1 and T2, because we've got all the information that we need to work these things out. Let's work out T1 first of all. So we know our angle here, that's what we worked out earlier, the 120.599, and we're going to use the other formula on the formula sheet with regards to triangles, that is half BC sine A, and we're essentially going to use that twice. So let's scroll down, what I just did. So let's work out T1. So T1 is going to be equal to, well, remember, use the formula. We need the angle in the middle and the two sides next to it. So we do half times 120 times 150 times the sine of the angle we worked out in the previous question. And notice I'm putting as many decimal places as I can down to reduce the idea of any rounding error. So let's type that into the calculator. So I'm going to use 0.5 times 120 times 150 times the sine of 120.599. And so I get this answer here, written down as many decimal places. I should in the future make sure the float, though the amount of decimal places used is a bit longer, otherwise my answer will be slightly inaccurate. So I'll go back and go 7,746.76. So, okay, so that was T1. For T2, we do a very similar process. So we start with the half, and we know 150, but we also know this side as well, because we worked this out earlier as 86.0. Let's see if we've got any more decimal places on that. So I scroll up. Yeah, so it's 86.0365. So it's worth writing that in. Okay, 86.0. The thing is better when you've got a calculator next to you. 365. Let me just write that in. Got it there. So we need to use the formula again. So half times 86.0365 times 150 times the sine of the angle, which is a nice precise answer in this case. Got 55. Excellent. And if we do that on our GDC, let's go back. So it doesn't matter what order you multiply in, of course. So let's write down the decimal before I forget. Times 0.5 times 150 times the sine angle, which I think was 55. So it's worth always checking these things. Go along. We get an answer, so 5,285.77. Okay, and just to make the video a little bit shorter, we just add together, so 7746.76. We add on 5285.77, and we get, I'll do this to 3SF as always, so 13,000. So I'll write that in, 13,000 meters squared. Remember we're doing it to 3SF, and then the 3 doesn't round the 0 up at all. So answer. Obviously it takes a bit longer on the video, working between the GDC and the document, but you can see the clear method that I used in order to work it out. And my number 9 is proportionality or variation, and different teachers use different words for this. This can appear on paper 2 and paper 4. Make sure you're happy with some twists on it as well, and you'll see that in the very last part of this question. So y is inversely proportional to the square root of x. I'm underlining the key information here. And then we're given some initial conditions, which we'll use later. and we want to find y in terms of x. So we're going to write down our proportionality statement. As soon as I see the word proportional, I think proportionality statement. And let's go through this carefully. So y is proportional to, or inversely proportional. So we're going to write 1 over, because it's inverse, and then the square root of x. So we're going to write the square root of x. This then gives me the equation. So we transfer this into an equation, and the way we do that is by putting a k for where 1 is. So we get k over root x. Check out my video on proportionality. That will go through this in much more detail. At this point, we then substitute these numbers in. So when x is equal to 25, y is equal to 4. This reminds me the x goes here and the y goes here. So we go 4 equals k over root 5. Just take our time here. So 4 is equal to k over, well, the square root of 25 is equal to 5. If you're not sure in the exam, check on your calculator. It's the way to go. At this point, well, we want to get k on its own. So what's the opposite of dividing by 5? We want to times by 5. Both sides cancel, and so we're left then with the answer of k equals 20. Now that's not our final answer. Our final answer is when we put this k is 20 back in this original equation at the start. So our actual answer here, and I'll just remove some of the working so we can see it nice and clearly, is equal to, well, we know k is 20, so we put 20 back in here, and then over the square root of x for our 2 marks. Now what's typical here is that it gets you to substitute y to find x or substitute x to find y, and you can see both questions are here in B and C. So find y when x is 0.25. So when x is 0.25, y is equal to 20 divided by the square root of 0.25. At this point, okay, that looks more like a 6 than a 5. Let me try and write that a bit more clearly as a 5. Just put this into your calculator, okay? You can use your GDC or otherwise. 20 divided by the square root of 0.25, and that's equal to 40. Paper 4, use your calculator for straightforward calculations. This question works the other way round. So when y is equal to 5, you put 5 equals 20 over root x. We've got a slightly strange equation here, but we treat it in the same way. We want to remove the denominator, so I'm going to times root x on both sides. These cancel, then I get 5 root x is equal to 20. I'm going to copy this across over here so I have a bit more space. And we want to get the x on its own, so we divide by 5 on both sides. That gives us then root x is equal 4. And at this point you can do this mentally, or then think to yourself, well, what's the opposite of square rooting? Well, that's squaring both sides. That then gives us the answer of x is squared, which is 16. Pop in there. Again, at any of these points, you can use your calculator to help you work this out. Good. Now, the last question here is a little bit sneaky. So this time they've introduced a new variable z. Z is proportional to y plus 2. Then they give you the initial conditions in terms of x and z. So I'll show you how we go about this kind of AA stars kind of question. I write my proportionality statement. So z is proportional to, there's no inverse here, so it's going to be proportional to just y plus 2, which I'm going to put in brackets. That means that if we transfer this to an equation, this is where we have to be careful, then z is equal to some constant k, open brackets, y plus 2. Okay, brackets are really, really important here. Okay, this is why I put it in brackets here. At this point, you think, well, we don't have an x to work out what k is. We actually do, because if we go back to question A here, we have y equals 20 over root x. We already worked this out. So at this point, I can replace the y with 20 over root x. So I get z equals k, 20 over root x, is 2. Just substituting answer in from part A. Now at this point, I can then actually work out my new constant k using the initial conditions. So when x is equal to 4, z is equal to 84, and we just work through the algebra. So 84 is equal to k, open brackets, 20 over root 4, it's 2, 84, k, open brackets, well 20 divided by root 4, 20 divided by 2 is equal to 10. Use your calculator at any point here. Transfer this upwards here. We get 84 to 12k. 10 plus 2 is 12. Then k, and you can do this on your calculator or mental methods, will give you 7. So our new constant k is 7. And so we want to copy across this equation made here, but replace the k here with 7. So we get is equal to 7, open brackets, x plus 2. Another sneaky proportion variation question. So that's definitely a AA star part. It's quite unseen. It's not very, very standard by any means. The answers on the board, so you can check through what I've done here and see where you get your method marks. And the examiner's report, A and B were very standard and was done correctly. Some people didn't do this last part correctly, which is slightly embarrassing. So make sure you've got the square root of x equals to 4, and you have to square both sides. But this part was pretty well done considering it's not really a standard kind of question. So well done if you got question 10D correct. And definitely not to be forgotten, number 10 is volume, surface area and similarity questions, and often be combined together or they can be separate as well. So make sure you know how to use your formula sheet here. And I'm going to go for a pretty tricky question here. So you really have to concentrate hard. It's the very last part of the video. Okay, let's continue. So this is a pretty tough question. This is question 9. So we're going to look at some similarity first of all. And we've got two similar triangles, EAB and ECD. What the word similar means in this case is that they're in the same proportion. Okay, so imagine one is an enlargement of the other. And we need to show that EC is equal to 120 centimeters. So what that is the entire length of this line is equal to 120 centimeters. That's what we're looking to show. First of all, notice we've got two corresponding sides here. So we've actually got this side here, 15, and then we've got this side, 20. So I teach it slightly differently maybe to other teachers, and the mark scheme is also different. The way I do it is by working out the scale factor, which I generalize as big divided by small. You get 20 over 15. Okay, which if you wanted to, you could simplify down, of course. If you divide by 5 top and bottom, you get 4 over 3. Okay, please avoid decimals. Decimals will make your life a little bit more difficult. So that's our length scale factor here. So we've got 4 over 3. What we need to do now is use that to then work out this missing length. So imagine I don't know this length. So if I wipe this out, imagine I call this blue length that I highlighted earlier x. Yeah. So this length here, EC. Then the entire length of the line is equal to x is 40. This length is x, then to go from A to E, we just need to add 40 to x, okay? Now notice these are the corresponding lines of our small triangle and big triangle. So what we're asking ourselves is, okay, if I take x, our smaller triangle, I times it by 4/3, our scale factor, I should then get to my long length, which is x 40. This actually gives us a reasonably straightforward equation to solve. So this times together, we write this in good algebra as 4/3 x. This is actually a pretty straightforward equation. We minus x from both sides. Okay? So 4/3 x minus x. This is a 1x, so we get 1/3 x. Remember, 1 is the same as 3/3. 1/3 x, well, these two things cancel. So you get 40. And what's the opposite of dividing by 3? Well, we times by 3. Most you can see the answer here at this point. This cancels here. And we're left with x equals 120, which is good because that's what the answer should be, because that's what it says there. I've noticed many teachers don't teach it that way, but I think it's probably a more intuitive way than doing ratios of sides. I don't know. It's up to you how you want to interpret that question. Okay, we'll see the mark scheme at the end. Once we know that's 120, we need to work out the following things. So we need to work out ED and DB. So let's highlight what ED looks like. It's this length here. And if we think about it, we've actually got a right angled triangle. So we're looking for ED, aren't we? ED. Okay, so let's just take that triangle and so let's draw it separately. Essentially what I have here, a triangle where I don't know this, know this is 120 from what we just did, and we know this is 15. So essentially we can use Pythagoras on this question, just a straightforward Pythagoras question. So let me draw it onto this slide. This is 120, this is 15, this is x, and so Pythagoras says that x squared is equal to 120 squared plus 15 squared, so x is equal to the square root of those two things. This is I'm writing the minimum of working, but enough to guarantee me all the marks here. And this is where it's GBC. So we go onto a normal scratch pad, what you're familiar with, and we go control 120 squared, so you use the square button, plus 15 squared. Our answer here of 120.93. Again, we're going to round to 3SF, but we need to write down decimals first. And to three significant figures, which is generally expected, it's 120 centimetres. Okay, all good. Let's try and go back to a black pen. There we are. There's my black pen. And now we need to find dB, so let's have a look at dB and where that's. So dB is this length here. Okay, I think the most straightforward way, because we've already got this length here, we already know dE, we can use Pythagoras to work out the entire length of the line. I'm really having fun with my colours here. We can use Pythagoras to work out the entire length of the line, with 20 and this is 160, and take one away from the other to work out the short length. So let me go on to the next slide and show you what I mean. It was 20, it was 160. We've already worked out this part. This was 121. So we just use Pythagoras for the entire length. So if we call the entire length a sum y, then y is equal to the square root of 160 squared, 20 squared. Okay, and then to work out this length, call that s. S is going to be y minus 120.93 from before. And I will just skip to the answer at this point. You do that calculation, then get 40.3 significant. Okay, so the way I do part 3, again, slightly different to the mark scheme. I think they recommend use ratio similar sides, but I just use Pythagoras twice and then take one away from the other. Look for the most straightforward ways of being able to answer the question. Okay, and now the next part I do like. It's hard, certainly I can see this is the AA star material, but it really does test your understanding of similarity and your knowledge of volume of shapes. The diagram shows an open waste paper bin made from metal. Now this is actually important words that we'll talk about in the second part of the question. Open waste paper bin, so this is hollow, so to speak, so only this circle exists. Radius of the circle top is 20 centimeters, radius of the bottom is 15, perpendicular height of the bin is 40, and using part A, notice these lengths 40, 20, 15, these all correspond to this diagram here. Yeah, so notice that, we're going to use that later on. So, using answers in part A, calculate the volume of the waste paper bin. Now this shape is called a frustum, if I'm pronouncing that right, rating to work out anyway. And the way you work out a frustum is to think, if I extend these lines, now I'm going to kind of go over the question here, but just to show the point, essentially you're going to make a cone, yeah, a very big cone. So if you take the entire cone, okay, that's the entire shape including this bit. So the way to work out a frustum is to work out the, in this case, volume of the big cone, then minus the area, or the volume, sorry, of the smaller cone. Now, this is where you need to use your formula sheet, so let me write this up here. The volume of a cone equal to 1/3 pi r squared h. This is on your formula sheet, don't worry, you do not need to remember this. Absolutely fine. So, to work out the volume of this, we do, with the whole shape, we take the volume of the bigger cone, which is 1/3 pi times, now our radius is 20, Now you're probably thinking at this point, I don't really know the height. I don't know the perpendicular height of this. But if we think about it, we actually do, because we go back to the question we looked at before. The perpendicular height, remember? So the entire length of the line is the perpendicular height, which in this case is 160. We used it before, 120 plus 40 is 160. So this is where you're using your answers from part A. So actually we do have the entire perpendicular height is 160. We minus smaller cones, so we get 1/3 times pi times 15 squared times this perpendicular height. Again, we've also worked that out as well. That was actually given to us right at the start. It was 120. It's this length here. We need to type in 120. Okay, we do this, and this is where we're going to type this all into our calculator. So carefully, just need to be very careful as we do it. So I'm going to put this in brackets. So we got control 1/3 times pi 20 squared times 100 minus open brackets or fraction control divide 1/3 pi times squared times 20. Very important, yeah, we're using the answers from part A. And if we put that all into our calculator, we get the answer of 38,746.3. Always we're going to write down a few decimal places and then round to 3SF. So the 3SF is going to be 38,000. Which is the answer right here. Okay, and the very last part, which is the really tricky part, but we just have to think about this quite carefully. Now we need the area of metal needed to make the bin. Okay, so we need to think about exactly how we are going to work that out, the area of metal needed to make the bin. So just to remind you, okay, we've got the circle at the bottom that does exist. We've got then the curved surface area, which we'll need to work out as well. And then remember the top is empty, so we don't actually have a circle here. So give yourself a minute or so, have a think about it. How would you go about working that out? Okay, well it's going to be a very similar way to how we did it before. So we're going to find the curved surface area of the larger cone, and we're going to take away the surface area of the smaller cone, yeah? In the same way we did it before. The thing is, however, the formula for the curved surface area of a cone is equal to pi RL, okay? Where L is that diagonal length. So if I draw a cone, for example, pi R and L is this length here. And at first sight, we don't actually have that length, yeah? We don't actually have the length needed in order to work it out. But then we think, actually, we've already worked this out. We worked this out in the previous question here. Already worked out that green length, okay, which was part 2, that 120.933. We've already worked out this purple length here as well, which was using Pythagoras. We actually do have these lengths. So let's put this all together so we can actually work this out. Okay, let's put it all together. Let's start with the curved surface area of the frustum. Always forget if there's an R in there. Maybe you can correct me in the comments. So we're going to do pi RL of the bigger one. So that's going to be pi times 20. L was this calculation here. So I'm going to round. Now normally I would say not to round this, but just to show you exactly what's going on here, we actually do need to work out the length of the entire line. So we want EB. So we want this one here. I don't actually have a value for that, so I'm going to write it as this. So that's the curved surface area of the larger one. Then we're going to minus the surface area of the smaller one. So that was pi times 15, and then the diagonal length. So let's go back. I think it was it ED? It was ED, so it's this one here. I'm trying to avoid rounding errors as long as I can do everything. That should be a plus. This calculation works out the curved surface area of the frustum. So this part here. Okay, and what we need to do now is add in this extra circle at the bottom. Okay, so this is the bottom of the waste paper bin. So we need to add in a pi times 15 squared, the area of the circle. So go back, plus squared. And at this point, I'm going to put this all into my calculator. This is all about being very accurate here, making sure we've got everything written correctly. So go brackets. Let's see how this goes. I times 20 times, and open another bracket. So I'm going to put a square root in. You don't have to do this all in one step, but it's good to get used to being able to do this in one step. 20 squared. We're going to close that bracket, and I'm going to close that bracket again, making sure everything, so it should be brackets wise, good, and then minus, we'll do a similar calculation now. 19 times, open brackets, square root, 120 squared, 15 squared, get brackets, plus, and then we want this part now, so we've got y, some part of it, where we hope everything works out. This answer, which it is, good, that should be exactly as it is, 5,139. Okay, in fact, I think my answer is more accurate from theirs because they've rounded too early. So we've got 5,000. As you can see, the answer was acceptable. 5,139.3. Dot, 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 dot. That gives us the answer of 5,139. As you can see, it falls within the range of. So it doesn't matter. Sometimes, to a certain degree, it doesn't matter in terms of the rounding, because it lies within the range that they expect. Okay, so you get 4 marks for that. Notice, I haven't really written too much working there, but it's very condensed, yeah? This is the curved surface area of the large frustum. This is the curved surface area of the small frustum. We take one away from the other, and then we don't forget, of course, to add in the base circle as well. I'll put the mark scheme up on the board so you can have a look. It's been done slightly differently. Some of these questions, particularly part 3 and part 1, I've done it a little bit differently. Maybe you find it easier, maybe not. Okay, but you can see you don't need to write lots of working, but it needs to be clear, it needs to be obvious what you are doing to the examiner. Before I finish this video, I'm just going to look at the examiner's report. So the similar triangle situation that we encountered here is actually one of the most challenging questions on the paper. Which in some ways I find a bit surprising. There are other harder topics, but on a topic like my pupils, I've taught them in year 10, but then I haven't had a chance to really go through it. So it's something that gets easily forgotten. So question AI was actually quite badly answered, even though it was the first part. Part 2 was Pythagoras, which is good. Problem with getting A part I incorrect, well, you still got that value to work with, but it probably has an effect on your performance in part 3, because you don't see the similar idea. And a lot of people forgot about A to answer out B as well. Okay, so they forgot they could actually transfer their knowledge from A to B. And with the International Mathematics course, is a little bit on the non-linear side, unlike some of the other IGCSE courses. You do need to actually look through the previous question. The investigation paper, paper 6, is quite like that as well, where you have to use previous calculations to use in subsequent calculations. However, most people found the volume of frustum. That's sort of standard working out of the shapes. That's very, very good. And as we can see, that favourite word, discriminator, the surface area question was quite hard because many pupils did not realise to actually use the sloping heights from before. And as I pointed out, the area of the circular base was often omitted. It wasn't there. So this is a good question. If you want to get those A and A star grades, you need to be getting these questions right. Yeah, it's an area, if you're looking for those higher grades, really to focus on. So congratulations if you made it to the end of all 2 hours of video. Hopefully this has got you really well prepared for the IGCSE 0677 course. Please do check out my playlist just over here. So I have my paper 2 and paper 4 playlist, which goes through a lot of the things that we've gone through in this video, as well as my paper 6 playlist, which goes through the investigation modelling paper. All right, best of luck with your exam.